The mass of the entire solar system is mostly concentrated in the Sun, with the vast majority of its matter residing in the star at its center. This mass is essential for the Sun's energy production. Stars shine because the immense pressure and heat within them cause chemical reactions, specifically the fusion of hydrogen atoms into helium. This process releases a tremendous amount of energy, which is responsible for the heat and light of stars. The larger the star, the more matter it contains, and the brighter it becomes. In the vastness of space, there are objects like brown dwarfs, small star-like bodies that are not massive enough to sustain the nuclear fusion that powers stars. They shine dimly and are often referred to as failed stars. These objects are very dense, with their matter packed tightly together. Moving through the cosmos, we encounter even larger stars. For instance, a white dwarf is incredibly compact, with a mass comparable to that of the Sun, but the size of Earth. Over time, when such stars exhaust their nuclear fuel, they expand, cool, and lose their brightness. Earth's pole star shifts gradually over time. In a process known as precession, every 26,000 years, the North Pole traces a small circular path in the sky, pointing to different stars. Currently, the pole points to a supergiant star, which is vastly larger and brighter than the Sun. This star is located at the tip of the Little Dipper's handle. In the Milky Way, stars such as the blue supergiant in the Triangulum constellation, with a brightness 10 million times greater than the Sun, burn through their fuel rapidly and have short lifespans compared to smaller stars like red dwarfs. In contrast, these red dwarfs burn fuel slowly, meaning they can live for hundreds of billions of years. One of the most famous stars is Betelgeuse, located in the Orion constellation. This massive star is around 700 times the size of the Sun and could easily engulf the orbits of planets like Jupiter and Mars. It is expected to explode as a supernova in the next few thousand years, creating a spectacular celestial display visible even during the daytime. The largest stars are often hypergiants. One such star, although thousands of times brighter than the Sun, could contain 1 billion suns within its volume. These stars eventually collapse and may even form black holes. Among the oldest and most massive stars, UY Scuti stands out as one of the largest, with a radius 1,500 times greater than the distance from Earth to the Sun. It is a variable star, meaning its brightness fluctuates, and it has an incredibly high rate of energy consumption. Another enormous star, Stephenson 218, is so massive that it could hold billions of suns within it. These stellar giants serve as reminders of the vastness and complexity of the universe. Subscribe the channel